Welcome everyone. In this video, I am going to talk about two algorithms related to finding the minimum spanning tree of a weighted graph. What is a minimum spanning tree? A minimum spanning tree in a connected weighted graph is a spanning tree that has the smallest possible sum of weights of its edges. To understand this, first we will focus on Prim's algorithm. If you look at this weighted graph, right now it is not a tree because it is connected, but there are a lot of circuits in this. Second observation I want you to make here, that this has 12 vertices. So if I have to write it as or draw its spanning tree, the spanning tree is going to have 12 minus 1, that is 11 edges, because we know that in a graph with n vertices there are n minus 1 edges. What is Prim's algorithm? Prim's algorithm tells you that you have to start with an edge with minimum weight. So for example, if you look at this graph, we have an edge with minimum weight, that is CD. We also have BF and KL, and all these three are of weight 1. So I can start at any of it. But suppose in this situation, when there is a tie, we can select any of it, and I selected CD. So in the step 1, when I select the edge CD, the edge CD has two vertices, one is C and another is D. So in the next step, I am going to look at all those edges which are either incident on C or D, and then out of all those edges, I am going to select the one with the minimum weight. And we will continue this process, right? When I say we will continue this process, means that suppose I selected CD and in the next step I selected CG. Now we have three vertices which are involved. One is C, D, and third one is G. Now on all these three vertices, whatever edges are incident, I am going to select the one which is of minimum weight. But when we are doing this process, we must have to ensure that at no stage we should create a circuit, because if the once we get a circuit, it will not remain a tree, because we are looking for a spanning tree, so it should be free from any circuit. So to understand this, let us write all the steps. So here I am going to write the steps that will be involved. And what are the steps? Steps are the process of choosing the edges. So here I will be writing the edges, and on the in the last column I am going to write the weight, right? Weight of each of the edge that I will be selecting. Before we start, we should be clear that how many steps will be involved. 11 steps will be involved. Why? Because in total there are 12 edges, 12 vertices. I repeat it. In total there are 12 vertices. So the graph will have 11 edges, and in each step I will be selecting one edge. So there will be 11 edges, there will be 11 steps needed, or 11 edges will be the part of the spanning tree. I hope it is making sense to you. So what is the step number 1? Step number 1 is I select the edge CD. So suppose I select the edge CD here, and I am writing it over here. See, one thing you can also do, let me do it for you because it will help you to understand it better. That let us select all those 12 vertices, and whenever I will be selecting an edge, I will be joining those vertices or those edges I will be putting over here also, so that there is no confusion. So I have the vertices A, B, C, D. Here we have E, F, G, H, and here we have I, J, K, and L. So in the step 1 we selected CD. I put the edge CD over here, and I put its weight, that is 1. In a step 2, we can clearly see that on C we have CB, whose weight is 3, CG, whose weight is 2, and DH, whose weight is 5. So out of all these 3, the minimum is of weight 2. So second stage I selected CG, and its weight is 2. So I wrote its weight. Third step, now we have 3 vertices. I select CG here also, I join. Now we have 3 vertices C, D, and G. So out of all these 3, I am going to look at each of the edges which are incident on either C, D, or G, and I am going to select the one with the minimum weight. So if you look at G here, we have an edge with weight 3, another edge with weight 3, On D we have an edge with weight 5. On C we have an edge with weight 3. So since there is a possibility of selecting any one of it of weight 3, I can select CB. And I repeat it, you can select at this stage, you could have selected GF also, you could have selected GH also, because they are also of weight 3. So I selected CB, and CB is of weight 3, so I write the edge with weight 3. In step number 4, I am going to select, and now once I have CB here, we can clearly see that we have an edge of weight 1, and without much effort, I have got BF whose weight is equal to 1. So I selected its that edge whose weight is 1. So BF is selected. Now on F we have an edge of weight 2 which is incident on F. On B also we have an edge of weight 2, so I can select any of this. On this also, like if you look at, sorry, this I already have selected, and other, like on G there is an edge of weight 4. On H there is an edge of weight 3. So we are getting an edge of weight 2 which is minimum, so I can select suppose AB here, and its weight is 2. So I am writing in the step number 5, I selected AB and I am writing 2. See, before I proceed further, I repeat the argument once again. What is the argument? The argument is that at every step we are going to look at all the vertices which are already the part of the tree, and out of all the vertices I am going to look at all those edges which are incident of all these vertices. So currently how many vertices are involved? 1, 2, 3, 4, 5, 6. So I am going to look at all the edges which are incident of these 6 vertices, and the one with the minimum weight will be selected. I hope it is clear. So which edge should I select next? So we have F here, and we can see that on this we have an edge of weight 2, that is FJ. If I look at other vertices like FE, this is of weight 4. If I look at AE, this is of weight 3, and on G also we have an edge of weight 4. So I believe that and you can clearly see that this edge should be selected, because at this stage this is the edge with minimum weight, and so its weight is 2, and I join this also. Now let us write the 7th step. So in the 7th step you can see that on J we have an edge of weight 3. This side, like IJ is also of weight 3, JK is also of weight 3, GK is of weight 4, GH is of weight 3, AE is of weight 3. So there are a lot of edges of weight 3, and I can select any of them. So let us select JK, right? So because this is of weight 3, and I again repeat, in case if you are getting multiple edges of same weight, you can select any of it. So I write the JK, and its weight is 3. Now in 8th step, what I am going to do, I am going to select so we have got a very good edge here. Means good means an edge with minimum weight 1. So without much effort I can select KL, and its weight is 1. So I wrote KL, and I wrote its weight is equal to 1. Now we have to select 3 more edges. Now see, I can't select GK, because if I select GK, a circuit will be created. Can I select GH? I can select GH whose weight is 3. I can select AE whose weight is 3. I can select IJ whose weight is 3. And so what do you think? Which one should I select? Let us select HL, right? Because its weight is 3. So I am selecting in the 9th step HL, right? Again I repeat, it is not the unique process. Someone could have selected AE at this stage and HL at the next stage, so that is not a problem. 10th stage, I am going to select AE because it is also of weight 3 and of minimum, so I selected AE. And finally in the 11th step, now see here I need to join I, so either I can select EI or I can select IJ. So if I select EI, its weight is 4, but if I select IJ, its weight is 3. So I am selecting IJ, and what I have got is an edge of weight 3. So the steps are completed. Why steps are completed? Because you can clearly see that what we have got is a tree, because it is connected and there is no circuit in it, and you can clearly see that there are 12 vertices, so the tree should have 11 edges, and in all the steps, in each of the steps I have selected an edge, so there are 11 edges in this. So what is the sum of weights of its edges? If you add it, 1 plus 2 3 plus 3 6 plus 1 7, 7 plus 2 9, 9 plus 2 11 plus 3 14, 14 plus 1 15, and 15 plus 9, so 24. So what we have got is 24. So what is the minimum weight of this, what is the spanning tree using the Prim's algorithm? So this is the spanning tree, and what is the weight of its spanning tree? That is equal to 24, right? So let us do one more problem of finding the minimum spanning tree using the Prim's algorithm. Okay, so let us do this problem. So there are 9 vertices, 1 2 3 4 5 6 7 8 9, and let us name them A B C D E F G H I. And since there are 9 vertices, how many edges will be there? 8 edges. So how many steps will be involved? 8 steps. So I'm going to write the steps here. I'm going to write the edges here, and I'm going to write the weight of those edges. And you are expected to do it like this, because you should not miss to write all these details. So what is the first step? To select an edge with minimum weight, and you can clearly see that we have an edge with weight 1. So I select EF in the step number 1. So EF is selected, its weight is 1. Now next step, I am going to select the edge, that is EH, and since the process is clear to you, I am not explaining, so I am selecting EH and its weight is 3. Now in the next step, I have to look at all those edges which are incident on either E, F or H, and going to select the one with the minimum weight. So you can clearly see that HI is an edge with minimum weight, so I am selecting HI, and here I am writing the weight of it, that is equal to 2. So by now you are clear that in Prim's algorithm we are maintaining the connectivity. We are not selecting edge which are not making the graph connected, right? Because we are going to see the Kruskal's algorithm, and in that our focus will be on selecting the edges with the minimum weight in spite of trying to make the graph connected, and in the end in Kruskal's also it will become connected. Okay. So what is the fourth step? Fourth step, I am going to select the edge, that is FC, and this FC is of weight 3, so I am going to write weight 3. In step number 5, I am going to select this edge CB, whose weight is 4, and I am writing 4 here. In step number 6, I am going to select BD, and BD, its weight is 3, so I am selecting, first I have selected CB, and then I am selecting BD, its weight is 3. In step number 7, I am going to select DA, because its weight is 2, so I selected DA, its weight is 2. And in step number 8, I have to select GH, because that's weight is 4, so I am going to select GH, whose weight is equal to 4, so I selected GH, whose weight is equal to 4. Okay. So what is the total weight? Let us count it. So 4 6 9 plus 4 13 plus 3 16 plus 2 18 and 4 22. So 22 is the minimum weight of this spanning tree, and it has 8 edges. You can see 1 2 3 4 5 6 7 8. So I hope the process of finding the minimum spanning tree using Prim's algorithm is clear to you. For your convenience, I am repeating the whole process. Process is that you start with one edge whose weight is minimum, and in case if there are multiple such edges, then I can select any of them. And then we have to select the next edge, but while selecting the next edge, I need to maintain the connectivity. By that what I mean, that suppose here I have selected EF, then I can't select HI, because if I select EF and then HI, then there will be no connection. So only those edges we are going to select which are either incident on E or on F, and out of all those edges which are incident on either E or F, I am going to select the one with the minimum weight. And in the process I also need to ensure that we should not create a circuit, otherwise it will not remain a tree. And the moment we arrived at the 8th stage, where I have completed all the vertices and kind of expand all the vertices, what we get is the minimum spanning tree. So the next thing that we are going to talk about is Kruskal's algorithm, and it is even easier than the Prim's algorithm. So to understand the Kruskal's algorithm, the first part is that here there are, if I look at this problem, how many vertices are there? There are 12 vertices. So I am going to place those 12 vertices here without much delay. So let me place those 12 vertices and then I will explain the details, and let me name it A, B, C, D, E, F, G, H, I, J, K, L. And how many steps will be involved? So in this also the total steps involved will be 11. Why? Because there are 12 vertices, so number of edges will be 12 minus 1, that is equal to 11, right? And here I will be writing weight. So steps, edges and weight. What is the process here? The process here is simple, that we have to start with an edge with the minimum weight. But in this case I don't have to be bothered about the connectivity. Our focus will be on selecting the edge with the minimum weight. So I can start with the first step, and in the first, suppose I select the edge CD here, because if you select the edge CD, its weight is minimum, so I selected CD. Right, I could have selected KL also, I could have selected BF also. So since all of them are of weight 1, so I selected CD and its weight is 1. Next step, without maintaining the connectivity, I am going to select the next vertex, or sorry, next edge with the minimum weight, and in this case I select KL, and this I join KL and its weight is 1. And in the next step I selected BF, whose weight is 1. So one thing by now is clear to you, that here I don't care about whether the edges are connected to each other. I have just picked all those edges which are of minimum weight. So there are 3 edges with weight 1, so I have selected all the 3 of them, right? Now we have to select those edges which are of minimum weight, and only thing that we need to make sure that there is no circuit that is completed. So the next edge that we can select is of weight 2, and suppose I select the CG. So I selected CG and its weight is 2, and I wrote it here. One thing is also clear, that here the weights will be in non-decreasing order, means it should be 1 and then 2 and then so on. It should never happen that you take 1 and then 2 and then 1 comes. That will be wrong. Now what will be the fifth step? Fifth step, I can select another edge of weight 2. So suppose I select FJ, and FJ is also of weight 2, so I wrote FJ here and its weight is 2. In sixth step I can select AB, because the AB is also of weight 2, so I selected AB, whose weight is 2. In the seventh step, let me draw AB also. And in the seventh step, now I don't have any more edge of weight 2, because this is of weight 2 I already have selected. This is of weight 2 I already have selected, that is CG, and this is of weight 2 which I already have selected. Now I am going to look at those edges which are of weight 3. So the first one I am selecting edge, suppose JK. So I select JK and its weight is 3. So I join them, JK. Next I am going to select 8th is IJ, and IJ is also of weight 3. So I selected IJ, right? So no concern here. Ninth is that I select suppose AE, because that is also of weight 3. So I selected AE and its weight is 3. 10th, do we have any more edge of weight 3? So I can select HL, because HL is also of weight 3. So I selected HL and that weight is 3. and 11th, that is the last stage. So I can select FG, right, or I can select GH. It both is possible, because if I select this also, there will be a spanning tree. If I select GH also, that will also be a spanning tree. So let us select GH, and here I got is the weight 3. So if you look at this graph, it has 11 edges, 1 2 3 4 5 6 7 8 9 10 11, right? And if you take the sum of it, it will be 3 5 7 9 and 9, and then how many 3 are there? 1 2 3 4 5. So 9 plus 5 15, that is 24, because there are 5 edges of weight 3. So 15 plus 9 is 24. And if you remember, when I discussed the Prim's algorithm, there also I got the weight, that is 24. So in Kruskal's also the weight will remain same. I hope you have understood the difference. The difference is that when I am solving the problem by the Kruskal's algorithm, I am not concerned about whether the edges are connected to each other. I'm just going to pick those edges which are of minimum weight wherever they are, that is important. And only thing that I need to be careful about, that we should never pick any edge at any step which creates a circuit, irrespective of what is its weight. Okay, so let us quickly solve one more problem related to the Kruskal's algorithm. Now I am taking the same problem which I have taken earlier and have solved it using the Prim's algorithm. So now I am going to solve it using the Kruskal's algorithm. So let us quickly write all those 9 vertices, right? And this is what the names are, like A, B, C, D, E, F, G, H, I. How many steps will be there? There will be total 8 steps, because there are 9 vertices. So steps, edge, and weight of each of the edge. So in step number 1, I am going to select the edge with minimum weight, and here that is EF. So let us select EF, and its weight is equal to 1. Now the next, there is no edge of weight 2, so sorry 1. So I am going to select the next of weight 2. So I can select HI because its weight is 2. So I selected HI, its weight is 2. In the third step, I can select AD because that's weight is 2. So I selected AD, whose weight is 2. And I already have exhausted those edges which are of weight 1 and weight 2. So the next I'm going to focus on those edges which are of weight 3. So in the fourth step, first I am going to select CF, whose weight is 3, and I am going to join CF here. I have selected AD also, so let me first join AD in the third step. Okay. Now what is the fifth step? So fifth step, I am going to select what is the weight. So CF I already have selected. I can select EH. So if I select EH, its weight is 3. So let us join EH. And in the sixth step, what I can select, any other edge of weight 3. So yes, BD is of weight 3. So I can select BD, and its weight is 3. Okay. So I have already selected this BD. I have selected EH, and I have selected CF. So there is no more edge of weight 3. So now I have to move to the edge of weight 4, and make sure that at no step the circuit is being completed. So in the last step, I am getting BD. So let me join BD here. Now 2 more edges should be selected. So next is of weight 4. So which one should I select? Suppose I select which one? GH I can select, right? Because that is of weight 4. So I can select GH, and GH is of weight 4. And what next I can select? I can select CB. So CB is also of weight 4. So I got CB, and its weight is 4. What I was thinking that when I selected GH, some of you might have been possibly selecting CB. So that is not a problem. Here also when I selected these 3 edges like HI or AD, I could have selected them in the other order also, like first I could have selected AD and then I could have selected HI. And when I selected these three edges of weight 3, then also the order may be different. I could have selected B, D, E, H or CF in any order. But what is important is that at every stage I am selecting the edge with the minimum weight, and in the process I am making sure that it is not a circuit. So now in the end, what we have got, what is the sum here? 1 plus 2, 3 plus 2, 5, 5 and then 9. So 5 and 9 is 14. And 14 and plus 8 is 22. So 22 is the weight of the minimum spanning tree, and this is the spanning tree because it has covered all the vertices and there are total 8 edges in it. So I hope both the process of finding the minimum spanning tree using Kruskal's and Prim's algorithm are clear to you. These are very important topics, so you should solve some more problem. And I hope you are enjoying the video, so make sure that you like the video also and share with all your friends. Thanks for watching.